Hello, my name is Mark Karadimos, and this is MATHguide.com. Today we're going to take a look at fractions, and we're going to talk about how to reduce them. Alright, so what is a fraction? A fraction is just a ratio of two numbers. So anytime you're taking two numbers and we're going to compare them. Let's take these two, for example. Let's say we have 12/18. And we'd say, okay, it's a great fraction. We're comparing 12 to 18. What we'd like to do is think of this in smaller terms if we could. And it turns out that actually, for this problem, we can. So you'll notice that both of these numbers are even. So I could divide this number by 2, and I could divide this number by 2. So if you could divide the top and the bottom, the numerator and the denominator, by the same value, you can do that. You could divide by these common factors, they're called. Alright, so we'll do that. Now if we do that, you'll notice that 12 divided by 2 is 6, and 18 divided by 2 is 9. Alright, well, it's definitely, the numbers are smaller than we started, except these numbers too can also be reduced. For instance, I could divide the top by 3 and the bottom by 3. So I could divide the top and the bottom by 3, which will allow me to reduce this fraction one more time. So 6 divided by 3 is 2. 9 divided by 3 is 3. And since these can no longer be reduced because they contain no common factor, we say that it is completely reduced. We've reduced the fraction. Okay, let's try one more. See if we got the hang of this. I'm going to try numbers that are a bit bigger, so they might take this, might take a little bit longer. There might be a longer process to this. Now, eventually, people get better at this, and they don't actually show the division. They start to do some of this kind of, instead of vertically, they start to do it more horizontally. Let me show you what I mean by that also. Okay, like for instance, I could divide, again, I could divide the top by 2, and I could divide the bottom by 2. I'm doing this a little bit smaller, so I could actually show. Let's see, 100 divided by 2 is 50. 180 divided by 2 is 90. Alright, well, I could reduce some more. I could divide this by 2 again. Now, and I can divide this by 2. Now, if you see a bigger number, it does speed up the process. Like, okay, I can divide by 2, and I can divide this by 2. And let's see, I'm going to get, divided by 2 is 25. Divided by 2 is 45. Okay, so I'm getting some smaller numbers as I'm going down the line. Here I'm going to divide this by 5. I'm going to divide this by 5. Okay, and I'm going to bring that down over here. So it looks like I'm getting, let's see, 25 divided by 5 is 5. 45 divided by 5 is 9. And it looks like I cannot reduce that any further. Okay, so I'm just going to show that that would be the final answer. Now, back over here, you might have noticed that we could have done this faster. So let's say we start with 100 over 180. I can draw that a little bit neater. Let's say I find a number that's larger that allows me to divide. Like, for instance, they end in zeros. Well, I know I could divide it by 10. And let's see, if I divide that, I'm going to get 10. Divide that, I'm going to get 18. That's pretty quick. Except I could divide by more, right? I could divide that by 2, and I could divide that by 2. So if you could divide by larger numbers, it speeds it up. So the last time I did it, or I should say the first time I did this problem, it took me 3 steps. If I divide by larger numbers, you could see that it takes only a couple steps, 2 steps. So, but I'm getting the same answer. Now, does it matter if it takes you longer than someone else? No. As long as you get the correct answer, that's what's more important than how many steps, unless your really time is crucial. Alright, so make sure you go back to MATHguide.com, check out our other videos, our other interactive quizzes. Take care.